Hello and welcome back to Introduction to Physics. Today we're going to be doing a lab on harmonic motion. So you're going to want to go to Canvas, and then Modules, and then Labs, and then the Unit 3 labs on waves. And then when you open up that document, you're going to go to the bottom, and you're going to click on the tab that says Lab 15, Harmonic Motion. So that's the lab that we're going to do today. So we're going to be using both a pendulum and a spring for our lab, and I'm going to expect you to have some string and have an object that you can tie to it or tape to it in order to make a pendulum. Okay, when it comes to the spring, I'll show you how to do the lab, and then you can take data based on what you see off the video. Okay, so first thing is you need to read the concept introduction. So go do that right now. Okay, you back? Okay, so now you're going to go down to the pre-lab questions and you're going to answer those. So what's the purpose of the lab? So go down into the lab to where it says the word purpose, and then you can copy and paste that in there. Safety instructions, so if there are any, you can copy and paste those. The definition of the frequency of an oscillator, so that is in that concept introduction. And then what is the period of an oscillator? This is important because you're going to be measuring both the frequency and the period of a pendulum and a spring. Then number 5 is what is the spring constant of a spring? You're going to be calculating that today. And then what happens to the amplitude of an oscillator over time if it's damped? So I'm looking for basically the definition of damped harmonic motion. So when that's occurring, what happens to the amplitude of the oscillations? And then on question number 7, when an oscillator is in resonance, again, what happens to the amplitude of the oscillations? So if this still isn't clear in the lab, just look it up on Google. So look up the word damped harmonic motion and then resonance. And then you could also go to videos and it would show you an example of each of those. Alright, so now let's go down into the lab itself, and for the first experiment, which is going to be on pendulums, you're going to need a ruler, a stopwatch, some string, and something to tie onto the end of the string. Now I would recommend a ball, but it doesn't have to be, so you can make a pendulum basically out of anything. And if you can't tie it onto the ball, then you could duct tape it onto the ball. But you will need that. You're going to need, I would say, about 2 meters of string, or about 6 feet, because I want you to make a really long pendulum, and then that way you can make a shorter pendulum that you're actually going to measure. Alright, now I'm going to let you read through the concept introduction, but note that you are going to be using equation 15.1, which is the number of times that something swings back and forth. Now, this is one swing. So this is not one swing. So when it says number of oscillations, this is one oscillation, and then if it does it again, that would be 2 oscillations. So the number of times that something swings back and forth divided by the amount of time it takes you to do it in is going to be the frequency. And I know that thing looks like a V, but it's called nu, and it's a Greek letter, and it stands for frequency. Now in your textbook they tend to use the letter F, a lowercase f, for frequency, but this is the same thing. Okay, then equation 15.2 is how you calculate the frequency of a pendulum. So 15.1 is how you're going to measure the frequency of the pendulum and the spring. 15.2 is how you're going to calculate the frequency of the pendulum. And then equation 15.3 is how you're going to calculate the frequency of a spring. So you're going to be making use of all three of those equations. Okay, you're also going to be needing equation 15.5, which is how to find the weight of a mass, or the force of gravity acting on a mass. And then you will also be using equation 15.4 to calculate the spring constant C of a spring once you know what its weight is using 15.5. So we'll get back to that later. Okay, so let's go down to part 1 of the lab, which is the pendulum. So it says to assemble a pendulum of length L with a mass M suspended from it. Now, if you instead of using a ball, let's use a can. Okay, so get a can of mushrooms, or a can of tomato sauce, or a can of tomato paste. So a small can of something, because on the outside of that can it's going to tell you the mass of the amount of material that's inside of it in grams. So if you always look on the outside of anything that you buy at the store, it tells you what its mass is in grams. Now that doesn't include the mass of the can itself, but you can approximate and say that really the mass that's on the can is the mass of the ingredients plus the mass of the can. So don't worry about that. So go ahead and write that mass down, okay, in grams. Convert it to kilograms by dividing by 1,000. Okay, measure the length of your string. So I would, even though you've got a piece of string that's 6 feet long, I would recommend maybe measuring about 50 centimeters of string and then tying it onto that can. So you want to measure the distance from where you're going to hold the string to the center of that can. That's going to be the length. Measure it in centimeters and then change it to meters. Okay, then once you got that all tied up, you're then going to pull it out and you're going to let it go back and forth, and you're going to time with the stopwatch or with your cell phone, how long does it take to swing back and forth 10 times. And you're going to record that number. Okay, then you're going to calculate the frequency by using equation 15.1, because you know the number of swings and you know the amount of time. Then you're going to calculate the frequency of the pendulum using equation 15.2. Now remember, you're going to need to know the length of your string in order to be able to do that, and it must be in meters. And hopefully those two frequencies will be the same. Okay, then it says what happens to the frequency if you shorten the pendulum. So you don't need to do the experiment again. All you need to do is shorten the string, pull it back, let it go, and see, does it go back and forth faster or slower than it did before. And then you might also want to use the full 6 feet of it and see, so make it longer and see what happens. You might also want to try what happens to the frequency if you increase the mass. Now again, you don't have to do any of the calculations, but this time tie on a heavier soup can and see what happens. It has to be the same length as you did before though. And then what happens if you pull what happens to the frequency if instead of pulling it out this far, you pull it out this far? Okay? And see what happens to the frequency. Okay, I'm going to stop the video here, and when we come back, we're going to talk about springs.